Hello friends, it's another time to solve baadhi ya maswali na after that I hope tunaweza either tukaendelea na lenses this time or another time. Naanza na swali la kwanza. Light is incidence on the air water interface at an angle of 40. So angle of incidence I is equal to 40 degree. Given that the refractive index of water is 1.3 is 1.33. Determine the angle of reflection of light in water. From Snell's law, ambao alisema refractive index is equal to sine of angle of incidence divided by sine of angle of refraction R. So from here ni kwamba refractive index is equal to sine of 40 divided by sine of R. To get sine of R itakuwa sana sine of 40 gawanya kwa refractive index. R will be equal to sine inverse of sine of 40 gawanya kwa refractive index. Actually this is not n, kwa hiyo sio kaandika to n. R is equal to sine inverse of sine of 40 gawanya kwa 1.33. So you get angle of refraction R is equal to sine ya 40 gawanya kwa 1.33. 0 hiyo hapo sine inverse tapata ni 28.9. 28.9. One thing you need to remember is that the angle of refraction R must be smaller than the angle of incidence, kwa sababu hapa light ilikuwa inatoka kutoka kwenye air to water. Kwa hiyo angle of refraction R lazima iwe ndogo kuliko angle ya incidence. Namba 2, a stone is lying at the bottom of the pool of water 3 meter deep. What would be the stone's depth B as seen by an observer standing by the pool? Refractive index ya water tayari naijua ni 1.33. Kwa hiyo manake kama hiki ni kisima cha maji, hapa anasema a stone is lying at the bottom of pool of water 3 meter deep. That means the depth of water is 3 meter. This is the real depth. Lakini from there water kama imejaa mpaka pale, a stone is here. So a stone will appear to be raised. And here will be having the apparent depth. Kivipi raising inatokea tulishaelezea. Hizi concept zote zinatokeaje tulishazielezea. Kwa hiyo finally mtu akiweka jicho lake pale atakuwa anaona stone iko raised. Kwa hiyo tunachoulizwa ni kwamba what would be the stone's depth B as seen by an observer standing by the pool. Refractive index tunaijua. Remember we said refractive index is equal to real depth gawanya kwa apparent depth. Kwa hiyo tukitaka kupata apparent depth maana yake itakuwa sana real depth alafu gawanya kwa refractive index. So real depth itakuwa sasa na ilikuwa ni real depth ilikuwa ni 3 meter. So itakuwa 3 meter gawanya kwa refractive index ambayo ni 1.33. So you get 3 divided by 1.33 tapata ni 2.26 meter. This will be the apparent depth, or it will be the depth of the coin. Itakuwa ni stone's depth as seen by an observer. The speed of light, this one in water and this one in air. Determine refractive index from air to water. Hilo swali ni simple na sitalifanya. Refractive index from air to water is equal to speed of light in air gawanya kwa speed of light in water. It's very simple. A ray of light travel from air to water is incident at the surface of water in angle of 30. Calculate the angle of refraction. Ilo pia sitalifanya. So I left this question number 3 for you. A swimming pool appears to be 1.5 deep. Appears to be. Manake ni apparent depth. Apparent depth. Ukishambio appears to be. Appear, it is apparent. Kuapia manake inaonekana iko hivyo, lakini it's not actual. So appears to be 1.5 meter deep. 1.5 meter deep. If the refractive index of water ni 4/3, refractive index is equal to 4/3, awire 1.33, is the same thing. Then determine the real depth of the pool. Real depth of the pool naipataje? Refractive index is equal to real depth gawanya kwa apparent depth. So the real depth of the pool is equal to refractive index times apparent depth. That is to say refractive index 4/3 mara 1.5 will get 4 divided by 3 times 1.5, unaona, will get 2. So the real depth is 2 meter. The real depth of the pond is 2 meter. Real depth here, swimming pool. Number 5, diamond has a refractive index of 2.24. 2.24. Given that the speed of light in a vacuum is 3 times 10 power, determine speed of light in diamond. Very easy. Refractive index is equal to refractive index from air to diamond is equal to speed of light in air gane kwa speed of light in diamond. The speed of light in diamond itakuwa sana speed of light in air gane kwa refractive index from air to diamond. Refractive index tumepewa kwa kutafuta hapo inakuwa very easy. The critical angle for diamond. How do we get the critical angle? We say the refractive index is equal to 1 divided by sine of critical angle C. Hii 1 itokea wapi? Itokea kwenye sine at C. So from there to get the critical angle tutasema sine of C will be 1 divided by refractive index. So to get the critical angle C will be equal to sine inverse of 1 divided by the refractive index. We already have the refractive index. We'll get the value of C. Finally, question number 6. Tuna the critical angle for total internal reflection between water and air is 49. A beam strikes air-water boundary and undergoes total internal reflection. Will the beam stay in air? Will the beam stay in air or in water? Hilo ni swali la theory, nitaomba ulijibu kupima kile ulichokielewa. Lakini B, explain what happens when a beam of light from air strikes the surface of a calm lake at an angle of 50. What happens? Explain what happens when a beam of light from air strikes the surface of calm lake. Unaona? Hii beam strikes an air-water boundary. Beam strikes an air-water boundary and undergoes total internal reflection. Will the beam stay in there? Haya, na hii B, explain what happens when a beam of light from air imetoka kwenye air imestrict the surface of the calm lake at an angle of 50. What will happen? So this marks the end of our discussion regarding the refraction. In the coming sessions we'll be discussing about the refraction of light by lenses. Lenses zinafanyaje reflection of light. Thank you. Let's meet in the coming session.